Assalamualaikum. We are going to be presenting chapter 6 about plots. There are 4 of us, which is Farah Ilyana binti Zahanapi, Ni Aina Suha binti Ni Ahmad Khan, Suhailah binti Hishamuddin, last but not least, me, Hanis Najwa binti Muhammad Hisham Khan. For the table content, we have introduction, objective, methodology, analysis to demonstrate the step of analysis using RStudio, results, conclusion, and benefit of the analysis. For introduction, there are many types plotting in plots, which is simple plots, histograms, normal probability plots, stem and leaf plots, bar chart, pie chart, scatter plots, box plots, and function plots. For this group presentation, we were doing plots in R programming. In R, plotting is handled by a variety of R packages. Plotting in R may be very sophisticated and a very valuable tool for data analysis. The plot function in R is a simple function that may be used to create graph and chart for display. In the R programming language, it is implemented as a plot. The plot function accepts a wide range of data frames for various circumstances and types of objects. In the ArcGraphic package, the plot function is usually used to create two-dimensional graph to examine data set distribution or to illustrate relationship between data variables. Several graphs, such as scatterplot and line graph, are often used chart for exploratory data analysis and are constructed in R using the plot function. Objective. A histogram is a graph that shows the modes, spread, and symmetry of a set of data. Pie charts can be used in presentation to show a proportionate distribution of a sample. The scatter plot is used to study the connection between two continuous variables. A basic bar chart is a visualization that displays the frequency distribution of categorical variables. A normal probability plots can help identify whether or not a sample is chosen from a normal distribution. If all the points fall along a straight line, the distribution is normal. If the data points break from a straight line, the data is not normally distributed. A box plot is a graph that displays data from a 5-number summary. A box plot provides an excellent sense of how the values in the data are distributed.
Methodology. The methodology for this group presentation discusses and explains the data collection and analysis methods that we use in our study. This is the general structure to analyze the data in the study, which are scatter plot, line plot, histograms, bar plot, pie chart, stem and leaf plots, bar charts, pie charts, scatter plots, box plots, and function plots.
The next is analysis. In the part, we will demonstrate the step of analysis using RStudio. This data as for example to do a plotting. Firstly, scatter plot. This is the R code for scatter plot. Plot, opening bracket, x, y, mean x left, y left, x lim, y lim, axis. X is the data set whose values are the horizontal coordinates. Y is the data set whose values are the vertical coordinates. Mean is the title of the graph. X left is the label in the horizontal axis. Y-lab is the label in the vertical axis. X-lim is the limit of the values of X used for plotting. Y-lim is the limit of the value of Y used for plotting. Axis indicate whether both axes should be drawn on the plot. This is when you run the code in the Art Studio. The next is for line chart. The R code for line chart is plot opening bracket V type column X lab Y lab. V is a vector containing the numeric values. Type takes the value P to draw only the point, L to draw only the lines, and O to draw both point and lines. X lab is the label for x-axis. Y lab is the label for y-axis. Main is the title of the chart. Column is used to give colors to both the point and lines. In this slide, show how to run the code of line chart. The next slide is for histogram. The R code for histogram is histogram opening bracket V main X lab X lim Y lim brace column border. V is a vector containing numeric values used in histogram. Min indicates title of the chart. Column is used to set color of the bars. Border is used to set border color of each bar. X-lab is used to give description of x-axis. X-lim is used to specify the range of value on the x-axis. Y-lim is used to specify the range of values on the y-axis. Break is used to mention the width of each bar. So in this slide show you the command of histogram. Then this is the stem and leaf plot. The next is for bar plot. The code is bar plot hash xlab ylab main names the arg column. Hash is a vector or metric containing numeric values used in bar chart. Xlab is the label for x-axis. Ylab is the label for y-axis. Main is the title of the bar chart. Names.arg is a vector of names appearing under each bar. Column is used to give colors to the bars in the graph. So this is how you run the command of bar chart. The next is pie chart. The code is pi x labels radius mean column clockwise. X is a vector containing the numeric values used in the pie chart. Labels is used to give description to the slides. Radius indicate the radius of the circle of the pie chart. Mean indicate the title of the chart. Column indicate the color palette. Clockwise is a logical value indicating if the slices are drawn clockwise or anti-clockwise. So in the next slide, show you how to run the command of pie chart. The last one is box plot. The code of box plot is box plot as data notch var with names mean. X is a vector or a formula. Data is the data frame. Notch is a logical value set as true to draw a notch. Var width is a logical value set as true to draw width of the box proportionate to the sample size. Names are the group label which will be printed under each box plot. Mean is used to give the title to the graph. In this slide, show you how to run the command of plot.
For the result part, our group used t-test and ANOVA table, also multiple linear regression in R programming. This is the dataset that we use. We have car type, without, and with add column. In this video, I will show you how to run t-test and ANOVA table using R programming. T-test, the purpose of t-test is to find the difference of mean y between two groups. T-test is used to determine whether there is a significant difference between set of values among two groups or population. Three main types of t-test is one sample t-test, pair t-test, and two sample t-test. This is the example of how to run t-test in R programming. This is the given situation for this example. During a prior study, 22 cars were test driven using the additive. The mean number of kilometers per liter was 10.5. Question 1. Are the cars in the present trial running more efficiently than those in the earlier trial? For this question, I will use one sample t-test to run in R programming. First, I rename the dataset. The dataset from worksheet, I will rename it to dataset for make it easier for me to run other data. So this is the code, and this is the result. Next, it was given means prior was 10.5. And to calculate the current mean, this is the code. And when I run, it shows the result 13.86364. To test the one sample t-test, this is the code t-test, and when I run the code, it will show you the p-value and also the mean of x. So based on the result, this is the hypothesis h null mu1 equal to 10.5 and h1 mu1 must not equal 10.5. The p-value shown here 1.6, 1.066. So the decision here, when the p-value is lower than alpha 0.05, the decision we must accept h1. The conclusion is there is a significant difference between present and earlier trial tests. Second question, does engine efficiency improve when the additive is used? In this question, I will use pair t-test, which is repeated measure, to run the data. This is the code of how to run pair t-test. Here, the result is shown. The dataset without and dataset with add. So the p-value is 2.244, and it also shown the mean difference for both data. So the hypothesis for this question, h null mu1 must equal mu2, and the other hypothesis h1 mu1 must not equal mu2. The p-value we get from the result that we run just now, and it is lower than alpha 0.05. If the p-value is lower than alpha, we must accept h1. The conclusion for this question, there is a significant difference in engine efficiency between with and without additive. So the last question is to show you how to run two sample t-tests, which is compare mean values. Third question is, does engine efficiency with and without the additive differ between manual and automatic car? This is the code of how to run the two sample t-test. The result is p-value is equal to 0.4953. And it also show you the sample estimate. Mean in group 1 is 8 and the other group mean is 9. Hypothesis for this question, H null mu1 must equal mu2, H1 mu1 must not equal mu2. And the p-value it shows earlier 0.4067 is bigger than alpha 0.05, so the decision we must accept H null. The conclusion is there is no significant difference in engine efficiency between manual and automatic when using additive. For without additive, the p-value is 0.5953, which is bigger than alpha. The decision we must also accept H null, and the conclusion also there is no significant difference in engine efficiency between manual and automatic when not using additive. Next, I will show you how to run the ANOVA table using R programming. This is the code for with add. So the result here show you the p-value 0.4067. So the hypothesis is H null, mu1 must equal mu2, H1, mu1 must not equal mu2. The p-value here 0.4067 is bigger than alpha 0.05. The decision is accept H null. Conclusion, there is no significant difference in engine efficiency between with and without additive. So next, we run the ANOVA table for without column. So this is the code of how to run, and this is the result 0.4953. The hypothesis is H null, mu1 must equal mu2, H1 mu1 must not equal mu2, and the p-value 0.4953 is bigger than alpha. Decision we must accept H null, and there is no significant difference in engine efficiency between with and without additive. Okay, that's all for the t-test and ANOVA. In this video, I will show you how to run multiple linear regression models in R programming. So because our data, we have two independent variables, we must use multiple linear regression. This is the code of how to run multiple linear regression model in R programming. When I run this code, it shows you the coefficient. So the result here, the regression equation is equal y equal to 15.36 minus 1. And the value is negative, means that x decrease, y also decrease. So to interpret this result, when x cut, which is cut type, decrease by 1 unit, y with x also decrease by negative 1 unit. This is to
Conclusion for this project. These segments explain how to create the most popular plot types, which are simple plot, scatter plot, and line plot, histograms, normal probability plots, stem array plots, bar charts, pie charts, scatter plots, box plots, and function plots. One of the biggest advantages of plotting data in graph form is that it gives us a visual of the data that we can use to better see how the data is behaving and make observations and predictions based on that behavior.
Benefit of the analysis. Based off the demonstrate the step of analysis using RStudio, we found that it is easier for us to read data that have large amount using plots. Plots are simple to understand, and the lesson learned from them remain in your mind for a long time. If you believe there is too much data and want to convey the lesson learned from that data to your audience, the plot is the perfect tool. The only care you must take is to choose which sort of plots is most suited to your data points. It is not difficult to write code or syntax once you have found the proper type.